Now, coming to solubility. First of all, what is solubility? It is the amount of solute in gram present in 100 gram of solvent, right? Amount of the solute present in 100 gram of the solvent. Yes, Sharat Chandra.
సార్ గుడ్ మార్నింగ్ సార్
Yeah, Nana. చెప్పండి.
అటెండెన్స్ లిస్ట్ లో అంటే హర్ష కూడా అని చెప్పేసి ఉన్నారు సార్. ఒక్కసారి రీజన్ చెప్పారా? హర్ష గౌడ్
వచ్చినట్టున్నాడుగా.
నేమ్ సార్, తన నేమ్ హర్ష అనేసి మనకి ఎవరు లేరు. బట్ మరి
హర్ష గౌడ్, హూ ఇస్ దట్?
వేరే డివైస్ తోటి లాగిన్ అయ్యి నేమ్ చేంజ్ చేసుకునే ఆప్షన్ పెట్టింది.
అవునవును, నేను ఇవ్వలేదు. నా దగ్గర అన్ని కంప్లీట్ గా రీనేమ్ చేసుకోవడానికి లేదు నా దాంట్లో. కరెక్ట్.
ఓకే సార్, అదే ఒకసారి నేమ్ గురించి. ఓకే సార్.
ఓకే ఓకే, నో ప్రాబ్లం. రైట్. ఓకే గైస్, amount of the solute in gram present in 100 gram of the solvent is solubility, right? Now, see if small w gram of solute is present in, say, capital W gram of solvent, right? Small w refers to the weight of the solute. Capital W, the weight of the solvent. Now, as per the definition, 100 gram of solute is present in how many gram of the solvent? Okay. No, it has to be little opposite, right? Just a second. Because 100 grams is the weight of the solvent. So now let us consider it as, say, if W gram of the solute is present in capital W gram of solvent, then 100 gram of the solvent will be having how many gram of the solute? This is what is solubility, right? Now, therefore, solubility can be given as small w by capital W into 100. Okay. Weight of the solute by weight of the solvent into 100. Now, because it is a ratio, it has no units. Okay. Now, let us see the factors that influence solubility. First of all, factors that influence solubility of a solid in a liquid. Okay. We have about 4 factors which influence the solubility of solid in a liquid. The first one is nature of solute, and then the nature of solvent. Okay. Of course, we have temperature and then pressure. Okay. Now, let us take the first two. I mean, the nature of solute as well as a solvent. See, there is a general saying, like dissolves like. This clearly explains the effect of the nature of solute and solvent on the solubility. What does this indicate? What does this refer to? You know, polar solutes, I mean ionic ones, dissolve in polar solvents, right? Polar solvents like water, liquid ammonia, etc. Similarly, the non-polar solutes, I mean covalent ones, dissolve in non-polar solvents. Like benzene, carbon tetrachloride, etc. Okay. Polar solutes dissolve in polar solvents. Non-polar solutes dissolve in non-polar solvents. Overall, it actually depends on 2 factors. Let me see. Whether a particular substance dissolves or not can be explained on the basis of 2 things. One is lattice energy, the other one is hydration energy. Dissolution depends on 2 factors. Let us take case 1. See if hydration energy is greater than lattice energy, then of course it dissolves. I can say that it is a soluble. What do you mean by hydration energy? See, it is the amount of energy released when a substance is dissolved in water. In general, we call it solvation energy. Similarly, what is lattice energy? That means I can say that in general, the hydration energy is exothermic, liberated. In general, it is liberated. Now, lattice energy is the energy that is required to break the lattice. See, if the energy that is liberated because of hydration or solvation, if at all is more than what is required to break the lattice, then only it will be soluble, right? Case 2, the other way. See, if lattice energy is more than the hydration energy, that means if the energy required to break the lattice is more than what is released when the substance is dissolved in water, then there won't be any dissolution. I mean, insoluble. Okay. Now the effect of temperature. Solid solute plus a liquid solvent gives rise to solution. Say this is the equilibrium that exists when a solid is dissolved in liquid, when a solid solute is dissolved in liquid solvent. Now, when there is an equilibrium, we know that it follows Le Chatelier's principle. See, according to Le Chatelier's principle, we have two cases. See, if the dissolution process is endothermic with increase in temperature, solubility increases. A known fact. If the process is endothermic, which in fact requires heat, increase in temperature increases solubility, right? Now, if the dissolution process is exothermic, Okay. With increase in temperature, solubility decreases. We know that for endothermic reactions, increase in temperature favors the reaction, whatever it may be. If it is a forward reaction, it is favored. And if the backward reaction is endothermic, it is favored. Similarly, if the dissolution process is exothermic, with increase in temperature, solubility decreases. Simple, two things. Now, what are solubility curves? See, solubility curves are those which are drawn between solubility and temperature. Solubility on y-axis, temperature is taken on x-axis. If you see the curves, then they'll be like, in case of sodium nitrate, potassium nitrate, sodium chloride. With increase in temperature, solubility increases. Because in these cases, the dissolution process is endothermic. Okay. Then this is ceric sulfate. In this case, I mean, in case of ceric sulfate, the dissolution process is exothermic. So the solubility is decreasing with increase in temperature. Okay. Now coming to the effect of pressure. See, the effect of pressure is in fact negligible on the solubility of solids in liquids, because pressure generally doesn't have any effect on the solids. So simply I can write it as pressure does not have any effect as the solids and the liquids are highly, in fact, solids are highly incompressible, even of course the liquids also. They are highly incompressible. Gases are highly compressible, but these are not compressible. So there is no much effect, no significant effect of pressure on the solubility of solids in liquids. Now the second one. Solubility of gases in liquids. This, of course, is very interesting. It also depends on 4 factors. They are the nature of gas, then the nature of liquid, and temperature as well as pressure. Okay. Now, among these, the effect of pressure on the solubility of gases in liquids is interesting. Let us go for that. See, in general, the effect of pressure on the solubility of a gas in a liquid can be given by Henry's law. Now, Henry's law can be given as solubility of a gas in liquid is directly proportional to the pressure of the gas or pressure applied on the gas at a particular temperature. S is directly proportional to P. Solubility is directly proportional to pressure. Can also be given as M is directly proportional to pressure. Here this M refers to the amount of gas dissolved. M, the mass or amount. Okay. Now this is the basic relation. It can be modified. Now later on, Henry's law was modified by Dalton. It was in fact applied to a mixture of gases when dissolved in a particular liquid. it can be given as, according to Dalton, it can be given as PA is directly proportional to XA. Say this PA refers to the partial pressure of gas A in the mixture of gases. I mean, this refers to something in gaseous phase. Now, what is XA? This refers to solution phase. It can be given as mole fraction of gas A in the solution in the gaseous mixture, this one. So PA is proportional to XA. Greater the partial pressure of gas A in the mixture, greater is its solubility. So greater is its mole fraction in the solution. If more is a partial pressure, then it will be more soluble, and so its mole fraction will be more in the solution. That is what it actually says. Partial pressure refers to the gaseous phase. Mole fraction refers to the solution. Now this can be modified. PA is equal to KH into XA. Removing the proportionality and writing the constant. Now this is Henry's law constant, or simply Henry's constant. And this, of course, is Henry's law, the mathematical representation of Henry's law. PA is equal to KH into X. Okay. Now let me give you some other points. Relation between KH and XA, if at all is considered, these two. Now these two are, see, told you that XA is nothing but the mole fraction. In fact, it refers to solubility. So let me tell you that KH and XA are inversely proportional. Greater the value of KH, lesser is the solubility. Okay. Now, see, in general, KH increases with increase in temperature. Therefore, with increase in temperature, it can be given that the solubility decreases, isn't it? Because KH and solubility are inversely related. But with increase in temperature, KH increases. So when temperature is increased, solubility decreases. Now we can also take a graph This is again very important. Partial pressure is taken on y-axis. Mole fraction is taken on x-axis. See, because they are directly proportional, we get a straight line passing through the origin. So here the slope can be given as h. Okay. So that is a graph between partial pressure and the mole fraction.